Assalamualaikum everyone. Assalamualaikum everyone. A very warm welcome to all of you. I hope you are doing great and are excited for today's session. My name is Ikra Abid and I will be your host for today's event. On behalf of Empeer, I would like to sincerely thank each one of you for joining us for session 2 of our DevOps Decoded series. It's wonderful to have you with us again as we continue this series, and a special welcome to everyone who is joining us for the first time. Today, we are bringing you another opportunity to explore practical side of technology and gain insights from an industry professional. Our today's session focused on DevOps in industry and shipping your first app. We will explore how DevOps fit into real world industry environments and how application move towards deployment. And we have an interactive experience planned for you as well. After the technical session, we will have a DevOps quiz followed by a question and answer session where you will have opportunity to interact with our speaker. So we encourage everyone to stay engaged, participate actively, and make the most of today's session. Without further delay, let's get started. Before we move into the main session, let me briefly introduce Empeer. Empeer is a tech community by Empeer DevLab created to bring students, developers, and tech learners together through learning, collaboration, networking, and industry exposure. Our community focuses on creating opportunities where learning is not limited to theory but is connected with practical experience and the real world technology ecosystem. Through Empeer, we organize different activities and events, including workshops and seminars, labs and demos, networking and mentorship, training and certification, hackathons and challenges, final year project and industry talks. Our aim is to create a space where you can learn new skills, connect with others, exploring technology, and grow together as a community. Before we move forward, we also love to know a little about our people joining us today. If you like to introduce yourself, feel free to jump in. Please raise your hand. We will unmute you one by one. Before we move towards the main technical session, let's take a quick look at what Den Hour is all about. Den Hour is designed to bring together community, technology, learning, and discussion in one engaging session. Our regular Den Hour include different segments such as welcome and introduction, tech news of the week, founder spotlight, interactive question answers, and open discussion on major technology and industry updates. The idea is to create a space where you don't just listen, you also get the opportunity to participate, interact, and stay connected with what's happening in the tech world. So we encourage you to stay connected with Empeer and be part of our upcoming community session as well. Now let's talk about what we have planned for today. Our main focus will be DevOps in industry and shipping your first app. We will begin with the technical session where our speaker will take us through the topic and share practical industry insight. Once the session concludes, we will have a DevOps quiz, a fun opportunity, test your understanding, challenge yourself, and finally, we will open floor for a question answer session where you can interact directly with our speaker and ask your questions. So stay with us throughout the session and make the most of this opportunity. And now it's my pleasure to introduce our speaker for today. We are delighted to welcome Bilal Haider, Cloud and Infrastructure Engineer and Certified Kubernetes Administrator. Bilal brings expertise across several important areas of modern technology, including DevOps, cloud infrastructure, platform engineering, Kubernetes, production systems, CI/CD. His expertise in these areas giving us opportunity to look beyond theory and understand how DevOps concepts connected with real world infrastructure and application delivery. We are excited to learn from his expertise and practical industry experience. And before I hand it to our speaker, just a quick reminder, we also have a fun DevOps quiz planned at the end of the session, so make sure you stay with us. until the end and get ready to test your knowledge. Bilal, the stage is all yours.
Assalamu alaikum. Am I audible?
Yes,
Okay, so let me briefly introduce myself. As you know, I am Bilal Haider. I've been in the industry for more than 4 years. I started my career as a full stack engineer, and then I transitioned into DevOps and platform engineering. Okay, so let's quickly move towards our slides. Okay, Ikra, my slides are visible.
no,
Okay, now.
visible.
Okay, so let's start from our agenda. So we will be starting from Docker. Then we will learn something about images and containers. Then we will discuss some production workflows, and then some Docker commands, then Docker files, volumes, and we will be having a live demo. Okay, so before starting, if anyone has any question regarding anything DevOps, Docker, he can simply raise your hand and we will unmute you and we will ask your questions as you will uh, raise your hand. Okay, so first starting from that, why Docker was introduced. So this is a very famous meme that it works on my machine. Uh, for example, you are a developer and you made a Node.js server. Okay, and you made it on some Windows VM. You will put your code to GitHub. And for example, I'm a second developer or some DevOps guy, and I have an Ubuntu machine. And when I will try to run your code, there are a very high chance that it will crash because there are a lot of differences in the dependencies, in the libraries, in the OS system, kernel. So eventually, when working in the big teams, this problem becomes bigger and big and bigger and bigger. So with the time, the concept of Dockerization was introduced. Actually, before Docker, we have to discuss that what is containerization. So, a containerization is a method that bundles an application code, files, and libraries into a single lightweight package, which is independent of the platform on which it is running. So, for example, you have Windows laptop, and you have coded your application in a Windows OS. So once you will containerize it, it will be independent of the platform. So anyone having Ubuntu, Red Hat, CentOS, uh, Apple, anyone can run that application because the containerization has the power to isolate that application and it will install all the dependencies, libraries, everything that will be needed to run that application. Okay, so now comes to the Docker side. So Docker is just a tool for containerization. There are also other tools than Docker in the market that are used for containerization, but the most famous and the most old one is the Docker. So Docker simply provides a containerization platform that will help you to containerize your application. Means it will help you to package your applications, all the libraries, packages that will be needed to containerize. Okay, so if anyone has a question regarding container, he can raise your hand and we can unmute you. Okay, so let's start from Docker image and Docker container. So what is a Docker image? Let's suppose you have got a brand new laptop and now you want to install VS Code in it. So what you will do? You will go to google.com and you will firstly download the VS Code file. That thing that it is simple file. Okay, so we can call it as an image. Once that file, it probably of 1.5 GB. Once you will open that file, it will open a setup for you, and eventually, after following some steps, it will convert into into a running application. So you can say that that file which contains all the libraries, packages, and everything, that single file of 1 or 1.5 GB is a Docker image. And when you have executed that image into a running application, you can say that it is a container now. Okay. So I think that we are good with image and container. So let's move to the practical side. How we will start? We will start from Docker Hub. We will search some images. We will pull that image and we will run the container. Don't worry for these fancy terms. We will get through all of that. Okay, so first towards the Docker. How to install Docker? This is I think that should be the first question that should be here. To install Docker, you have multiple choices. You can install it from Microsoft Store. If you are on a Windows, you can directly download its binary or executable files from the Google, or you can simply install it from the commands. So installing Docker is not a big thing. For example, install Docker in Windows. Okay. So you will open this link and it will download a simple file for you of Docker desktop, and then you will have Docker on your laptop. Okay. So over a Docker, there is another application that is called Docker Desktop. So what Docker Desktops do? Docker Desktop help you to manage everything in GUI. Before this, Docker was all command based, and in the production levels, in the Ubuntu and other things in the industry, Docker mainly runs as a command line tool. But for the ease of developers, this tool was introduced that is called known as Docker Desktop. It helps you to see that what containers are already running, what images you have locally, and what are the logs of your container, if any application is running, what are the volumes and everything. Okay, so let's explore Docker in detail. First of all, let's go to Docker Hub. So what is Docker Hub? Docker Hub is an official website of Docker where all the images, majorly open source images, are pushed. So for example, you have made a Node.js server. Okay. And now you want to give it to someone, or you want to give it to some DevOps guy for the deployment. How you will do? Normally, you will push that code to the Git, and then that guy will pull that code or do something. But again, the problem arises that when he will pull the code and will try to run the application, there can be multiple issues regarding the OS, regarding the libraries, and many things. Okay, so Docker Hub is similar to GitHub, but here you push the Docker images instead of direct code. So, for example, you want to run Python, you want to have some Nginx, uh, Postgres, MySQL, Mongo, anything. You can have that Docker here. For example, if I want to run Mongo as a Docker, I will go here. I can search there in the search bar, or I can go directly. Okay, there I can see that what is the documentation, what is the community, what are the tags that are deployed. Tags mean versions. Okay, for example, this is a 8.3.7 novel version. This is 8.3.7. Which version has vulnerabilities of which category? What is the size of the application? So there are a lot of things in the Docker Hub that you can see. For example, you have okay, let me give you a scenario. For example, you are running a project on MySQL 8 version, okay, and I have given you a code that runs on MySQL 5. What you will do? You have only one option, that you will uninstall the MySQL 8 version and you will install the MySQL 5 version. But if you have a power of Docker, you can simply go MySQL. You will search for MySQL. You will go for Docker official image, and then from here you can see you can get the MySQL image. So you have multiple versions of MySQL. For example, you have MySQL 9, and as you scroll down, you will have MySQL 8, 7, 5, and everything. So, what is the advantage of running MySQL in a container rather than installing it into your laptop and then running? So actually the Docker provides, or when a container is run, it runs in an isolated environment. So it doesn't depend on which things are running in your laptop or your PC. For example, if the MongoDB is running, some Node.js task is running, anything is running, it will not be affected by it. But once you have run the application as a process after installation, it is dependent on many things. Okay, so let's pull an image. What does the Docker pull mean? Docker pull simply means to download an image. Okay. Okay, we will experience this thing that we have already searched Docker Hub. Now we will experience the pulling of image. We will change that image into a running container, and then we will verify that it is running. Okay. So before that, let's go from some of the Docker commands that are used in the daily life. The most popular Docker pull. It is used for downloading an image from Docker Hub. So Docker Hub is just a repository, is just an artifact registry where Docker builds are already pushed. So whenever you want to run any Docker container, you first pull that image from Docker Hub, and then you will convert that Docker image into a running container. Okay. Then Docker run is used to run a container from an image. Docker PS is used to list all the running containers. RM to remove any container. Image ls for reviewing or what are the images in your local laptop, local PC that are already stored. Volume ls is used to see volumes. Right now, just forget the volumes. We will discuss it later. Okay, so let's run some basic Docker. Okay, so I have already Docker installed. Let's clear things. And if I use Docker PS, I will see nothing. Because I have no running container right now. Let's run a container. Uh, let's suppose I want to run MongoDB. I will search Mongo here. From there, I can see there are multiple versions of Mongo. Okay. By the way, the Mongo AB size is very big, so let's find something else. Let's suppose we want to run Ubuntu image. Okay, we have Ubuntu, we have a lot of things, and let's suppose we want to run the latest version of Ubuntu. So how we will run it? Latest version of Ubuntu. The tag describes that uh, what patch or what minor version is this. Okay, so let's Docker pull the latest version. Now the Docker pull, this command will simply download that image from the internet, from the Docker registry. Okay. Before that, uh, we can also discuss another thing that's Docker. As like a Git, Docker is also an authentic platform. The registries here are an authenticated registry. So, for example, if you want to pull or push anything into some private registry, you have to first log in into it. So let's sign into Docker. I am signing in from my official email. Now we can create. So the second question is that how to authenticate Docker, Docker Hub. So as there is a concept of PAT, personal access token in GitHub. Similar concept is in Docker. We will generate simply a new token. Let's say DevOps session. I will give it all the access for now, and I will generate it. Okay, so I will copy the login command, and now in the password we have to paste our personal access token. So as you can see that login is succeeded, it means that I can now push and pull images from my private repo. If you want to pull images from from public registries, you can also do it without login. So what command we were running at that time? I think it was Ubuntu. So it is downloading the Ubuntu image, multiple layers of in multiple layers. It is of 41 MB. So okay, it will take some time. In the meantime, I've already downloaded the Mongo images. The reason for downloading the Mongo images is because we will be running MongoDB because our application depends on it, and it is big in size. So I've already downloaded it. And let's discuss another thing, that what we will be doing. So in our previous session, we have deployed our Node Keeper app. In that, you can simply store your nodes in it. Okay, so we have deployed the front end on Vercel, we have deployed the Node backend on EC2 instance, and in for the database part, we use the MongoDB Atlas. That is the cloud for MongoDB. Okay, so we will not be exploring cloud much in this session. We will be focusing on Docker because Docker itself is a very big and complex topic. So what we will do first, we will firstly run the MongoDB locally using a Docker image. So we will replace our backend from using the cloud Mongo to our local deployed Mongo. After the MongoDB is deployed, we will be going to Dockerize our Node.js backend, and then we will run it also through Docker. Okay, let's see this. So our Docker image has been pulled. If I go Docker image ls, I can see that Ubuntu latest image has been downloaded here, which is of 45 MB, and when it is extracted, it comes to 160 MB. Okay, so let's start this image Docker run. We can specify dash d. Dash d means detached from. I will explain this also. Okay, I have to give some sleep computer. Okay, so you can see that we have run this container. Now, what's the difference between this and this? The Docker images command lists the images that are downloaded locally in our system, while the Docker PS command lists the containers that are running using the images. So Docker PS command is showing me that a container with this container ID is running. It is using Ubuntu latest image. And we have used sleep 600 command. So why I have used the sleep 600 commands? By default, some of the containers are not meant to run for infinite time. They are only limited to run for a specific task. So right now I have run the Ubuntu image and I have given it command sleep 600. Sleep 600 simply stops everything in the Ubuntu for 5 minutes. Okay, so if I go inside of this doc, don't uh, uh, don't get confused with this command. I'm just going inside of that container and showing you that what is inside of the container. So if I go and list here, that you can show that I can see everything that is in an Ubuntu OS. I can view the, if I run the top command, I can see that what resources that Ubuntu container is consuming. If I list who am I, it will show me that I'm a root user. If I do ls, it will show me my files and folders here. Now let's exit it. Okay. So basically, what we did right now, we just simply downloaded an image from Docker Hub of Ubuntu and we ran a container from it. Let's also explore this thing in Docker desktop app. So if I go to the Docker desktop app in containers, I can see that this container is running of Ubuntu latest, and I can simply stop, delete the container from here also. And if I go to images, I can explore my images here. The green shows that this image is in use. So from here, you can explore the things more easily using the GUI. Okay. So let's stop this container Docker RM and dash force. I need to write dash force because this container is already in a running state. So if I run Docker PS, there will be the thing. Okay, so running containers using this thing, Docker run is a very complex and it's not a good way to run the containers. For that, we will be using Docker compose files. So first, let's go to our repository. And in this session, I will be taking help from the cloud because in the last session I've got some feedback from student that I am not using AI in it. The main purpose of this session is to teach basics and fundamentals. So, but I'm using Claude for a simple task. For example, I will say it. I want a Docker compose file to run Mongo and with no persistent volume and also set envs in it. So it will be generating me a Docker compose file. So what is a Docker compose file? Docker compose file, this is a Docker compose file. And what Docker compose file has? Docker compose file has all the configurations that are needed to run a container. For example, we want to run a MongoDB. Okay, so first, firstly, what is the thing that we will be needing? We will be needing the image of what version of MongoDB we want to run. So we have specified that we will be running the MongoDB image 7. The second thing we have just give the container name. You can give anything here. We have give Mongo. We want to give it restart policy. We are saying that never restarts. It is under stop. It is not necessary. We can remove it. Then we are saying that what ports it need to be bind. Okay, so what is port? Whenever you run when you run an application that needs to be interact with other parts, it always run on some port. Okay, so by default, the MongoDB runs on port 27017. So we have binded the container port with our machine port. So the port here, the first one is our local machine port, and the second one is of the container port. So I can bind anything here. For example, I want to bind port number 27017 of that container with port number, let's suppose 100 of my laptop. Okay. So we can bind anything here. So this is the ports and some environment we are also giving some environment variables to the containers that are necessary. For example, what is the init database? What will be the credentials of our MongoDB, the root credentials. So let's run this thing. So for running container using this MongoDB file, we will be using this file is stored here, docker-compose.yml file. Docker compose up. Okay. So what Docker Compose will do? Docker Compose will simply fetch the Docker Compose file from the current directory in the directory where I am already running this command. Okay, it will fetch the Docker Compose file. It will run all the configurations from it, and it will run the container using this configuration file. Okay, so let's roll it out, and it is also giving us the logs of MongoDB. And now I think we are good to run our MongoDB. So let's explore it using MongoDB Atlas at MongoDB Compass. So what is a MongoDB Compass? MongoDB Compass is simple a GUI tool for exploring your MongoDB databases. So let's edit the connection. We have local deployed Mongo. We will giving some green color. Now the part it is running on our local host 27017. This is the same port that I binded there in the configuration file. Then in the authentication system, we are using the admin and password is admin123. Okay, when I connected, you can see that that my MongoDB is running and my MongoDB Atlas is also able to connect with it. So by just simply this small file of 10 files, you can run the MongoDB in your laptop. Okay. Uh, by the way, if you want to run MongoDB like the traditional way, you will first go to the Chrome, you will download its setup, you will install its setup, and then whenever you will start your laptop, it gets auto restart. You can control it also, but it's a headache when you are dealing with hundreds of applications like this. But when it comes to the Docker, you can simply run this application or run a MongoDB using a single command, and you can also close it. Okay. So one more thing. Let's run our application. Most of you already know that what application is this. So this is a .NET server. So it's a Node.js server, which is the backend for our NodeKeeper application. So let's run this. But this time we will be running it using not the MongoDB Atlas. The first URL that is pasted here is of the MongoDB Atlas URL that we used last time. But this time we will be using the container URL. So we are saying that connect to MongoDB, use the admin username, admin123 password, and connect it with localhost. And this is the container port. Okay, 27017 is the container port. Make this database and connect it as an admin. Okay, so we will be running it. I think this was the command. Yes. And also like it is started on port number 5000 as we have declared in our env file, and it is also saying that db is connected. So if I go to my frontend repo, I think it is already running on localhost 5173. If I open this, let's do sign up. Name Bilal Haider, password Bilal123, and it has already registered me successfully. Let's log in and now make first demo node tags DevOps, and let's create it. Okay, so you can see that, and if even I refresh, my data is persistent. Okay, so And if I go to my MongoDB Compass and I refresh it, so you can see that I have a database of iNotebook and I have users of Bilal Haider and I have node that I have created. Okay, so this was the concept of Docker Compose file, how you will pull an image from internet and how you will run a container from an image. If anyone has some question regarding anything, he or she can raise your hand. Okay, so let's firstly understand what are the Docker volumes. Okay, so whenever you run application, there are some applications that needs data to be persistent. Okay, let me first see the chat if there are any questions. How to do custom configuration in Docker? Let's say in Mongo, so those will be specified. Arham, can you explain that what is meant by the custom configuration in Docker? Okay, when he will reply, we can further talk on it. But let's understand what are Docker volume. So volume is simply a disk space that is needed for to uh, save data in it. For example, right now we are using MongoDB. Okay, we have described that what image will be used. We have described the ports. We have described the environment variables. But as soon as I will close this terminal, this Docker will be stopped, and we will lose the data. Why we will lose the data? Because we haven't persisted any data anywhere. So let's say Claude that now add a volume to our Mongo for data persistence. Okay. Before these agents and LLMs, we were used to go to the uh, Google and search for the configuration file, for example, Docker compose file for MongoDB. Okay, and it will be giving me this file that it is using this image and everything. But now, as the technology has evolved, we have AI models, so it is better to do the things using AI agents. So, for example, if I go to this link, I can see whole image file or whole configuration file here. So, before the era of AI, we were used to do things like this, but now Claude can do it because these are not very complex things. Okay, so what the Claude has done? The Claude has done, it has declared a volume here of Mongo dash data, and it attached that volume, it attached this volume Mongo data to our Mongo container. So now every data that will be stored inside of the data slash DB, it will be stored our Mongo data volume. This volume will be stored on our local laptop. Okay. So if I Docker, Docker compose up and in another terminal, if I write a command of Docker volume ls, okay, so you can see that it is showing me a backend Mongo dash data volume name. Okay, so how this name is made? This name is made that Mongo dash data comes from here, Mongo dash data, and the prefix of backend is actually my folder name. So my folder name is backend. So backend underscore Mongo dash data. So now if I run Docker, yes, my MongoDB is running. Also, I can see the logs here. And if I go here,
Bilal, your voice is lagging.
okay, if anything is there, we can unmute and can ask you. Okay, so I have refreshed the MongoDB, so MongoDB campus, and as you can see that our that database of iNotebook has gone. And even if I go to my application and I refresh, my note is gone. Why my note is gone? It is gone because that the first time when we ran the MongoDB, we haven't attached any volume in it. So the storage in it was the temporary. We have added nodes in it. We have added a user information. But as soon as I close this terminal, the data also got lost because we haven't attached any volume. It was running like this. But now we have attached a volume. So anything that I will be creating, it will be stored in the MongoDB, and the MongoDB, all data will be stored in our local volume. So let's test it. As you can see, there is nothing here. Log out. Let's sign up again. And let's submit it. Let's note to description, demo, session, note, and tags, volume. So you can see that here no to store. If I refresh, it is persistent. And if I go to my MongoDB compass, refresh it, so you can see that we have users and nodes here. Okay. So now this time it will be persistent. Why it will be persistent? Because if I do Docker volume ls, I can see that I have already made a Docker volume that will be storing all of the data of my Mongo container. Okay. So let's close this, and I have killed the Mongo container. If I run Docker ps, no container is running. And if I run Docker compose up dash d, dash d is just used to run in the d dashboard. You can say in a background. Okay. So if I run Docker compose, if I run Docker ps, so you can see that my container is again running. If I go to my Mongo compass, I have refreshes, my old data is still persistent. And if I refreshes my app, you can see that all of my data is persistent this time. So let's discuss another topic, and then we will be having a short quiz. And that topic is very important. It is of Docker file. So now, right now, what we see is that we have already we ran the container of someone that someone has already Dockerized. For example, the MongoDB container was Dockerized by the MongoDB team. Ubuntu container was Dockerized by some Ubuntu team. But what if you want to Dockerize your own application? For example, we need to Dockerize our this Node.js server. How will we Dockerize it? We will let's give it a command. Dockerize this Node.js server for me. Okay, for Dockerizing, you have to understand that what are the steps that's needed to be that are needed to run your application. In general, in industries, developers used to Dockerize the app. They define the Docker file and they write the Docker file. Uh, but a DevOps guy should know what Docker file is, how you can automate the Docker file, and what are the steps in it. For example, we have created a Docker file here. Docker file is used to containerize that application. Okay, so what it will be doing? It is using Node.js Node version. It will be using 20 version and Alpine. Alpine is just a lightweight. If we do this, it will not be an issue. But Alpine just mean that we are using a lightweight image. Okay. Then we will be setting our working directly. Uh, consider it as we are using cd/f. Okay. Now what we are doing? We are copying our package.json file. What our package.json file contains? It contains all the packages that are needed. For example, it wants bcrypt, it wants cores, it wants express, JSON web token. So we will be only copying the package.json file, and everything that starts from package. It will also copy the package log.json file. Then we will be running the npm CI. If we do npm install, it will not be an issue. We will be running npm install. After this step, all of our application packages are installed. So all the dependencies that needed to run that are needed to run our application, they are already installed. Now we will simply copy the code from our this directory from here. So what does this dot and dot mean? The first dot indicates your current directory, and the second dot indicates the container directory. So this dot means that everything in this folder, copy everything from here to dot. To dot means that we want to copy it uh, into the container. Okay, so we will be copying everything, and then we will expose for port number 5000 because we want to run our server, and then we will run command node server.js. So this Docker file is very easy. Simply, we are getting a node. We are copying, we are copying our dependencies. We are installing them. Then we are copying code, and then we are running our application. So let's Dockerize it. Docker build dash t backend p1 and dot. Okay. So what this command do? Docker build is simple. It will build our application. Dash T means tag. What is tag? Tag is the tag version of our application. I have tagged backend dash v1. For example, when I was doing Docker images, you were saying that it was saying Ubuntu latest. So Ubuntu latest is the tag. So we specify that what is this thing. I'm specifying that it is a backend and it is the version v1. And dot means that current context. So what it will do, it will find the Docker file in the current context. Current context means this folder where I'm running this file, where I'm running this command. It will find the Docker file from the current directory and it will build it. So it is building it. First of all, what it did, it installed the Node.js. You can say that it from docker.io, it gets the Node 20. Then it run npm. Then it started the work app directory. It copied our package.json file. It ran npm install. After it run the copy dot dot, it means every our code is copied in. And now if I go do Docker images, by the way, Docker images and Docker image ls do the same thing. Okay, so both syntax works. So if I see my images, you can see that I have an image of Docker backend dash v1. Now uh, we have an application, we have our image. Now we want to run it. So let's close our direct terminal from where our Node.js application was running directly as a node process. And now let's see our Docker Compose. Okay, by the way, when I asked the Claude to write me Docker file, it also created a Docker Compose for it. So what this Docker Compose is doing, the below part of the Mongo service is it was before. But what it did on the top, it has defined another service. Service means a container that needs to be that will be run in the future, or it contains the configuration for this container. Build dot means this thing. Um, build build dot means that we have to find the Docker file from here in the current context, and we will build it. We have specified our container name, restart policy, our ports, and our environment variables. Okay, and we have added another thing that is depends on Mongo. So it depends on this service. Once this service will be up, then this service will get run, because in the industry or in your normal projects, every time first your database has to be run in order to start your backend server. So it is it doesn't make sense if you are running your application before your database, because obviously it will crash. So we will be running it. If I specify command docker compose up, so it is again building the application, building the Docker container from Docker file, and is running my application. So if I run Docker yes, I can see that my backend app is running along the MongoDB. So I have container of backend, this me, and I have container of Mongo. So if I go to my Chrome and localhost 5000, I can see that hello coders of DevOps session. Okay, so now this application is the container form. It is not the direct Node.js start program. It is a containerized application that is running using Docker. Okay, so what another? Let's discuss another thing. In these two configurations, we can see that there is a difference. In here, we have specified image, and in here, we have specified build. Why this is? Because in here, we have already image. So when I will run the Mongo, it will first find the Mongo 7 image in my local laptop, and and if it will not find it, it will search it on the internet. And if it will also not be found, it will give me an error. But here we want to build our application. We don't want to get any image from a Docker Hub or anywhere. We want to build this application from this context. So, for example, if I have Docker images, I have my image here. Uh, Remember, I have built it. So, what if I do Docker compose down? I'm just forcing the Docker containers to be stopped. Okay, if I run Docker PS, so there is no container running right now. Okay, and if I want to run my existing image, what I will do? I will specify this backend app latest, and I will specify image and here. Okay. So if I docker compose up dash d, this time it hasn't built the Docker. It just took this image from my local PC and have run it. So if I give Docker PS, it will be using this same image which I have specified, and now it is running. I think that we can give the quiz.
Okay, Bilal. Uh, if you can just continue sharing your screen so I can share mine.
Thank you so much,
Yes.
Bilal, for such an insightful and engaging session. We truly appreciate your break, taking the time to share your knowledge, experience, and practical insight with our community. I'm sure today's session has given everyone a better understanding of DevOps in industry and the process of shipping an application. And now we are going to move from learning to a little bit of friendly competition. Here's a quiz.
By the way,
At
uh, let me just take 1 minute. If anyone has any question regarding Docker, he can ask anytime. Okay.
Okay, so can you hear me? If anyone can confirm, am I audible, Ikra? If you can
Yes,
confirm.
Saram, you are audible.
Okay, okay, that's good. So yes, my name is Amir, and I'm the co-host along with Ikra. As you know, this is the second episode or the second series of a webinar where we are trying to learn about the DevOps and its things. In the past previous section, we learned about Vercel and AWS-based deployment and its services, and now we have in this session we were learning about Docker. So this is just a small quiz that we have prepared for you guys to just to know how much you have learned. So Anas will be sharing the link via which you can join. And furthermore, if you can see my screen is visible, right?
Yes, Saram,
Yes.
it is visible.
That's good. So if you can just join by the link that Anas has sent in the WhatsApp, and also I've shared that link in the Zoom chat. So you can join it and then we can start, or you can scan the QR code that is visible on my screen. Sure. We have only three participants join, so I'm waiting for other of you to join. You can join via the link that has been sent in the WhatsApp group or in the chat of Zoom. So once we have some participants, then we can start and see how much we have learned. And it's an interactive gaming session. I hope you will enjoy that. So is everyone of you have joined, or should I wait? If anyone is joining, let me know as we can start. Okay, so we will join, start the game in just 1 minute, and let's see who wins it. Okay, so just to let you know, this format of this game is like there will be a question that you have to answer, and then you can submit your answer, and then the one who gives the correct answer and the answer fastly, the most quickest one would get the points out of it. So this is the format of it, and for each question, I will give enough time, like enough seconds, so you can answer them and then join the quiz easily. And there would be a total of 7 questions that would be randomly popping on your screen one by one, and in the end we can get to know and get to see like who's the winner. So I would say that's a good time to start. We have 13 participants, 20 participants in the Zoom meeting and 13 in the game. So let's start and let's see who wins. Yes, it started from my side, and you can get to see the answers or questions on your screen and also on my screen that is shared, and you can answer it. So for the first question, I'm giving the whole seconds, which is 20 seconds. So just you like to know about the platform and how to answer that. And the question, okay. Okay, so the next question is why do we use Nginx in front of a Node.js application? And for that, we have four options, and you just have 4 to 5 seconds to answer that. And after that, I would skip. Okay, so the correct answer for this was as a reverse proxy for SSL termination and load balancing. By the way, at the end, you can get to see the correct answers also. So the next question would be popping up in your screen, and that is what problem does DevOps aims to solve? And then you have four options below it that you can answer. You can read it out. I guess the options are long enough, so it would take some time to read. Just don't GPT or Google it. So the correct option here was friction and slow releases between development and operations teams. And I guess 8 of you got it right, which is good. So the next three is, what is the difference between a Docker image and a Docker container? This one you should get it right, because as this is already we have discussed and the options are lengthy, you can read it. I'm not skipping this question. Okay. Okay, so the correct answer for this is, an image is a read-only blueprint, a container is a living, running instance of the image. That's nice. Almost four of you got it right. And the next question is on the screen. That is, what problems does Docker or containerization solve? So you can read those options and try to find the correct one. Okay, okay. I think almost everyone got it right. We have to see if there is any hack regarding the bucket. So the next question on the screen is, what happens when a developer pushes code to GitHub in a CI/CD pipeline? And this is an easy one, I would say, out of the options that we have. Okay, so seven of you got it right, and that is, a webhook triggers automated build tests and deployment workflows. And then here comes the last question. Let's see what it is. What is the difference between continuous integration and continuous deployment delivery CD? So you have to select the correct one. I hope no one is using some lookat hack or extension that provides the correct answer. So let's see who wins this session, this quiz session. And almost eight of you got it right. And moving forward, we can get to see the results. Okay, 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 that's good. Let's take a screenshot of this. And you can let me know whether you can see the correct questions along with answers on your screens or not. Like someone might have given wrong answer but wanted to see the right one. You can let me know in the chat. I would say the chat is open. Yep. Stop. I think the chat is blocked still. So, anyways, this was the QA session, and congratulations, Arsalan and Miriam. You have won nothing but just prayers from our side that you have learned this DevOps in a good way. And moving onward, we would definitely do these type of giveaways or Q&As between the session and onboard some other things that are like credits, OpenAI credits, or Anthropic credits. We'll probably move towards that and moving in our next sessions. So yes, I would say this was a good one. And Bilal, you can take over and continue. Thank you.
Okay, I will not be taking a lot of time now. I will just take maximum 10 minutes from now. Okay, so we were here, and till now, what we did we pulled the images, we made the containers, we built the Dockers using Docker file. We have attached some volumes to our Docker containers for the persistent volume. So one thing I want to again describe is that what is the difference between Docker Compose and a Docker file? Okay, let's put both of them side by side. Okay, so Docker file is the blueprint of our application. Okay, Docker image is the blueprint that is made by Docker file. So when we build the Docker file, it converts into a Docker image, and the Docker file contains all the steps, commands, everything that is needed to be installed and run our application. For example, uh, installing our packages, copying our code, and then starting our server. Okay. And what is Docker Compose? Docker Compose is simply a configuration file that is needed to run our containers. So in actual, this configuration file is very easy, but when we are working in the industry, there are tens and 20 and 30s of Dockers that we need to run on every day, and we can't just run them using the command. Uh, so we managed our configuration files for running the Docker. So simple Docker Compose is a configuration file for running the container, while the Docker file is used to build the server. Okay. One more thing. So anyone hasn't questioned me that we have Docker images. Okay, we have built our application, but this Docker image contains to only my laptop. Okay, so if Aram is doing the work on same project, or if he's a DevOps guy, if he wants the image, how he will get the image from my laptop? So the answer is that we will push this image to some online remote registry. So let's look it. So as I have already stated that we have Docker Hub, that is the official Docker registry. So now we will be going to push our Docker image to this Docker Hub registry. For that, we will be creating a repository, just like in GitHub, we create a repository. Exactly the same way we will be creating a repository in the Docker Hub. Okay, it is asking me the name. I'm going to log notebook. Now it is description images for my notebook app. Now it is saying me that it should be public or private. I'm giving it private. Okay. It is your option. If your application code is open source, you want to make it build public, you can keep it public. If it's private, you can put it private. I will keep it private. Okay. So now uh, we are here. We have a registry, but this registry is an empty registry. We have nothing in our tags because there is no application or Docker image that is pushed here. So how we will push it? We will push it using Docker push command. Okay. So we will first tag the image to this. Bilal1311 is my username. Okay, so as every Git account in GitHub as a username, exactly similar way every account in Docker Hub has a username. So Bilal1311 is my username and Notebook is my repository name. Okay, so let's wait. And Docker, yes, Docker images, Docker tag. So what I am doing, I am tagging an uh, already existing image to another image. So if I do this, wait, V1. So see what happens. We have now a Docker this tag. Now, if we see it closely, we can see that this ID this ID and this ID is similar. Why? Because I have only tagged it. There is no functionality difference in it. There is no code difference in it. There is no difference in it. It is just like this is a file and we have renamed it to multiple things. So there is this one Docker image that has been tagged 3 times. So we have this tag, we have this tag, and we have this tag. So we will just push our build here. Let's suppose I am pushing my latest build here. Okay, if I execute this command, it is pushing and it is pushing in layers. Okay, so I can see that this is of 8.83 MB, this is 43 MB. It will take time. So, but by this, we will push our images to our remote Docker registry. So uh, understand Docker Hub is exactly like a GitHub. The difference is that GitHub contains the direct source code, while the Docker Hub contains the uh, con- contains the images, Docker builds. Okay. And by the way, one more thing that Docker Hub is not the only repository here. Okay. In the world, as like if we talk about the Git, we have GitHub, we have GitLab, we have Bitbucket, we have Azure DevOps, we have multiple Git remote servers. Exactly like here, the Docker Hub is not the only one. We have the cloud registries, for example, AWS, Azure. We have hardware, Nexus. So exactly similar way, we have multiple remote repositories also. Okay, it is going to take some time. If anyone has any question regarding Docker or even about DevOps, he or she can ask. Also, we can see everything in the Docker desktop app. If we see our images, we can see all of our images here. We can delete the images from here. We can run this image. So run, what will the run button do? Run button will only convert this image into a running container. Okay. Uh, as I have already stated, the run means to convert this image into a running container. We have containers and we can also see the logs. Okay, so if I want to see the logs of any container, for example, MongoDB, here I can see the logs, and also I can also you see the logs using Docker logs command, and then I have volumes here. I can see the volume. It is saying that it is of 300 MB, so I can delete the volumes and I can control everything from Docker desktop as well. Okay, so it is pushed, and now let's see it on the Docker Hub. Let's refresh it. So now we have this latest version of our code of our Docker build here. So anyone, any other developer in your project, any DevOps guy who wants this application built, he will simply only run this command docker pull Bilal Haider 1311 notebook, and this Docker image will be downloaded into his PC, his or her PC, and then he can simply run it as a container, as we have already seen, as a Docker compose or as a command. Okay, so let's move towards the slides. The Docker. So in the production, things work exactly like this. Only difference is that the build and the push, these things are done by in the CID, in CI/CD. So basically, what happens that some CI/CD is running on some server, for example, GitHub Actions, AWS pipeline or GitLab pipelines. It will take the code from Git, then it will build the code into a Docker image, then it will push that Docker image into container registry, that is Docker Hub or some other. And then on the CD part, the servers will pull the latest image or the specified build from the registry, and it will deploy and run. So this is exactly how things works in the production. We have already seen the live demo of everything. And let's just get a quick overview of Kubernetes. That what is Kubernetes? So actually, in production, in companies, we are dealing with a hundred of Dockers on a daily basis. For example, in my personal project, I have around 25 to 30 microservices. So you can say that we have 30 Docker images at a time, and every microservice has multiple replicas in it. For example, 5 to 6 replicas are running. So in total, at a time, my single application consists of 200, 150, 200 Docker containers. Okay. I can't manage that everything using just a Docker. So what is Kubernetes? Kubernetes just gathers all the servers that you have. It creates a cluster of servers. For example, you have 50 servers, you have 5 servers, or you have hundreds of servers. Kubernetes groups all the servers into a single cluster, and then you can run your Docker containers in Kubernetes. What Kubernetes will do, Kubernetes will find the right server for it, whose health is who is a healthy server, who has the resources, CPUs, RAMs. It will find that server and will run the Docker in it. And it will also, if any Docker container will crash, it will auto restart it. It will auto heal it. So Kubernetes is a complete ecosystem that provides a complete ecosystem for running your Docker containers in scale. So, for example, you have thousands of containers, thousands of microservices. Kubernetes can easily handle everything there. But if you run this through Docker, Docker has no capabilities of auto scaling. It can't auto heal the application. It can't do load balancing. Kubernetes can also provide Nginx and multiple load balancers. Uh, Docker does not comes with any deployment strategy. For example, rolling update, blue-green deployment. Kubernetes provides you with that, and a lot of core things. So, if anyone has any question here, he or she can ask. Other than this, we are good.
Anyone has question, please feel free to jump in.
So I think we can end the session. If anyone has any questions, he or she can ask in the group, and we will be available to answer it at any time.
And with that, we reached the today's end of